Okay, so what we're going to be talking about in this packet is statistical studies. And rather than me going through and reading, this page with you, I'd really like you to just go through and read just about the 3 types of studies. So I want you to read what it says about an observational study, a survey, and an experiment. So hit pause and do that. Okay, now if you, I just want you to outline, underline or highlight a couple key points. So an observational study, the main point here is that the subjects are just being observed as they are. Okay, the researcher is not manipulating the environment in any way. They're just basically observing what's happening. A survey, which is a type of observational study because nothing's being manipulated, is asking people a number of questions. And I'm sure everyone's participated in a survey of some form. And then finally, an experiment. An experiment is where the environment is being manipulated. Okay? Now, what's important here in an experiment, this word is really important, randomly. It randomly assigns the subjects to 2 groups. Okay, the control group and the experimental group. And the experimental group is manipulated in order to test a hypothesis, so in order to test whatever it is the study is trying to determine. So with an experiment, the environment is being manipulated, right, in order to test whatever they're trying to test, whereas with an observational study or a survey, nothing is being manipulated. They're just observing what's going on or asking some questions. Okay, we're going to just, if you read, I guess the bottom half of the page, it's just going to talk a little bit more in detail about an experiment. All right, so we already talked about what this says, but this just talks about some keywords with an experiment. A subject is a participant in the experiment. So you can just kind of underline the word participant. Okay, a subject is a participant. Okay, the response variable is the variable that's not controlled by the experimenter and that is measured as part of the experiment. So basically the response variable is what they're trying to measure by doing the experiment. And then the treatments are the conditions to which the subjects are randomly assigned. So, okay. This down here, this has some stars next to it because this is really important. Random assignment refers to randomly assigning subjects to treatment groups. So you're not, picking who you want to be in which group. You are randomly assigning which participants get assigned to which group. And random assignment is really important. That, if you can underline this as well, there's a lot of key things you have to know on this page, and you may have to, as you go through the packet, flip back to this page. But random assignment allows for cause and effect conclusions. So you can underline this whole thing. This is really important. Also, one other thing I do want you to write on your paper is that, let's just kind of, I really want to just kind of put a star next to this. Okay, cause and effect conclusions can only be formed through experiments. So, saying that the reason this effect is happening is because of this cause can only be formed through experiments. Okay, that can only happen when the environment is manipulated and all aspects are kept the same between the 2 groups other than the one thing that they're testing for. So the only thing that can cause, the only thing, that can basically form cause and effect conclusions are experiments, not observational studies or surveys. Okay, and then just if you can read this, it says the purpose of random assignment in an experiment is to create similar groups of subjects for each of the treatments in the experiment. Okay, so they're saying keep both groups the same other than what it is you're testing for. Okay, so if you can flip to the second page. I mean, the first page was just really a lot of, definitions. So now we're going to put those definitions into play. Okay, so it says, number 1, a manufacturer advertises that its new plastic cake pans bakes cakes more evenly. A consumer group wants to carry out an experiment to see if plastic cake pans do bake more evenly than standard metal cake pans. 20 cake mixes, same brand and type, are randomly assigned to either the plastic pan or the metal pan. All of the cakes are baked in the same oven. The rating scale was then used to rate the evenness of each cake. Okay, so what I'd like you to do on this page, letters A through E, it just asks you a bunch of questions based on this situation right here, and like explain why this is an experiment. Part B, identify the subject. So you may have to flip back and forth from the first page to this, but I'd like you to do your best to try to answer these questions based on what we talked about on the front page. When you're done, you can just hit play and see how you did. All right, so if you recall from the first page, in an experiment, you want to randomly divide subjects into two groups, right? And you want to assign treatments to them in order to measure some sort of response variable. Okay, so this is what I said. I said this is an experiment because the cake mix was, I'm going to underline this word randomly. This is really important. You always have to include that word to get full credit. Because the cake mix was randomly assigned to two types of pans, the control group and the experimental group, in order to determine the effects of baking evenness. So just to point out, the control group here is the, the cake mix that was put in the metal cake pans. So the ones that were given the treatment of the standard metal cake pans were the control group. And the experimental group was the cake mix that was assigned to the new plastic cake pans, okay, because they're testing if this, bakes cakes more evenly. Okay, now the subjects. Some of you guys might have got tricked and put the subjects as the pans, but it wasn't the pans. The pans, I'm going to actually jump down to part C for a second. I'll go back to part B in a minute. The treatments were actually the plastic pans and the metal pans. These were the treatments, right? One group was assigned to the plastic pans, and one group was assigned to the metal pans. So the pans were the treatments. Those were our two, I guess different conditions. Now, the subjects are the participants that were assigned these two treatments. So the subjects in this case was the cake mix. Okay, the cake mix is what were put into these two treatments. All right, the response variable in part D, it's really just what you're trying to measure. So we were trying to measure the evenness of each cake. And then letter E says, can an experiment be used to determine cause and effect? All right, that was something we kind of start off on the front page. Yes, only experiments can be used to determine cause and effect relationships. Remember, observational studies cannot. If you want to determine a cause and effect relationship, then you need to manipulate the environment. Okay, you need to keep basically all factors the same other than the one thing that you're testing for. So all factors had to be the same in this experiment other than the plastic pans and the metal pans. Okay, everything else, the temperature of the oven, the amount of time it was in there, the amount of mix put in, everything else had to be kept exactly the same. Okay, so I'd like you to read number 2 and see if you can answer part A and B on your own, and then hit play again and see how you did. All right, so it says, a study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls played a video game that they had never played before. The time it took them to reach a certain level of expertise was recorded. All right, part A wanted to explain why this was an observational study. So I just put, it was an observational study because the participants were just simply observed. The investigator did not manipulate any aspects of the study. Okay, they just observed, the boys and the girls playing the video game. And they determined the time it took them to reach a certain level of expertise. Okay, so then part B, can an observational study be used to determine cause and effect? So we talked about this in the last example. No, it definitely cannot be. Only experiments can. Okay, so if you can, again, just try number 3 on your own. Okay, number 3 gives you a situation, and they want you to identify the subjects, the treatments, and the response variables. And after you do that, you can hit play and see how you did. Okay, so I'm just going to kind of uncover my answers. So the subjects here were the jalapeno peppers, right? It was the plots of jalapeno peppers. They were the participants. The treatments were the watering schedules, okay? There was the watering 3 days a week and watering daily, okay? Those were the 2 different treatments given to them. And then the response variable, what they were trying to measure, was the heat rating. Okay, so pages 4 and 5, which is numbers 4 through 10, are all multiple choice questions. And based on what we talked about, from the first page of this packet and in examples 1 through 3, I'd like you to see how you do with these, okay? So just hit pause, take a few minutes, take 5 minutes, whatever you need, answer these questions, and then hit play and we'll go over them. All right, so the answer to number 4 is choice 3, right? We wanted to determine which of these is false. So with choice 3, it says observational studies can determine cause and effect relationships. I mean, this is not the case. We know that only experiments can determine cause and effect relationships. Observational studies, they can determine patterns in relationships, but they can't say that it was because of this one factor that it caused something else to happen. Experiments do that because you're keeping all the factors the same other than the one factor that you're, testing for. So choice 3 is the answer there. All right, so in number 5, the answer there is choice 4. And the key word is intervene. If you intervene, right, if you're kind of manipulating the environment, you're intervening, then that's going to be a controlled experiment. All right, so when you read number 6, the answer there is also choice 4. It's a sample survey. They're providing a list of questions to come up with data about the situation. So when you're giving a list of questions like that, that's called a survey. And the reason it's a sample survey is because they're not asking every single person. They're just asking a sample of the students. They're giving it to every student in the first lunch period. All right, so if you take a look at 7 and 8, you actually see that there's a new term there, census, which we haven't talked about yet. So just so you know, if you want to put this in your note, all a census is it's an official count or survey of a population. So that's where they're, surveying the entire population and making it official. All right, so number 7, the doctor wants to test the effectiveness of a new drug on her patients. She separates her samples of patients into 2 groups and administers the drug to only one of these groups. So because she's breaking them up into 2 groups and one group is getting the medication and the other isn't, this is definitely an example here of choice 4, a controlled experiment. Okay, she's manipulating the environment. She's administering them to one group and not the other. All right, when you read number 8, a market research firm needs to collect data on viewer preferences for local news programming in Buffalo. Which method of data collection is most appropriate? Here I would definitely say it's a survey. I mean, it's not going to be a census. They're not going to survey everyone. It's not observation. They're not going to sit there and watch who does what. And it's not a controlled experiment. They're not breaking them up into 2 groups. The best way to do this would just be to, put a survey the population, sample of the population, and that's, how you would get your results. Okay, for number 9, I'm just going to go through the answer choices one by one, but it says which scenario is best described by an observational study. So for choice 1, it says for a class project, students in health class ask every 10th student entering the school if they eat breakfast in the morning. All right, so I would say this one right here represents a survey, which technically a survey is a type of observational study, but let's see if there's a better answer choice. All right, choice 2, a social researcher wants to learn whether or not there is a link between attendance and grades. She gathers data from 15 school districts. Well, this would definitely be an observational study because she's observing through the records the link between students' attendance and their grades. So I'm going to say choice 2 is the answer, but let's just keep reading. All right, choice 3, a researcher wants to learn whether or not there is a link between children's daily amount of physical activity and their overall energy level. During lunch at the local high school, she distributed a short questionnaire. So there we go. There's a survey to students in the cafeteria. So this, I wouldn't say is the best answer either because choice 1 and 3 are definitely, surveys. And then choice 4, it says 60 seniors taking a course in advanced algebra concepts are randomly divided into 2 classes. One class uses a graphing calculator at all times, and the other class never uses graphing calculator. So that right there, they're dividing them into 2 groups, and each group is given a different treatment, right? One of the groups has one of the groups gets the calculators and the other doesn't. So I would say that that right there is a controlled experiment. Okay, so choice 2 is definitely the answer. And then for number 10, which task is not, I'm going to underline that, a component of an observational study? All right, so if we go through them, the researcher decides who will make up the sample. Yeah, that's a component. The researcher analyzes the data received from the sample. Is a component, yep. The researcher gathers data from the sample using surveys or taking measurements, yep. And then choice 4, the researcher divides the sample into 2 groups, with one group acting as a control group. No, that is not a component of an observational study. That's a component of an experiment. Okay, so I'm just going to put that. This is a component of an experiment. All right, so if you guys can turn to the next page, number 11, it says 2 studies are described below. One is an observational study, while the other is an experiment. So what I'd like you to do is just hit pause, read study A, and read study B, and then I'd like you to answer letter A through D on page 6, and then you can stop and see how you did. Okay, so letter A wants to know which study is the experiment. So I said study A was definitely the experiment here. I said the dogs were randomly assigned to 2 different groups. And I just want to point out, don't forget to use this word randomly. That's really important. Okay? So they were randomly, and look, you see it right here. They were randomly assigned to 2 different groups in order to determine the effects of the dog food on improvement in their health. Okay, so there was the control group who was given the current dog food, and then there was the experimental group who was given the new dog food. All right, so part B, identify the subject in the experiment. So the subjects were just the participants, which would be the dogs. So I wrote the 30 older dogs. All right, identify the response variable in the experiment above. So the response variable is really what was being measured. So the health rating of the dogs was what was being measured. And then letter D, identify the treatment in the experiment above. So the treatment would just be the new dog food and the current dog food. That's what, the 2 different treatments that were administered to the groups, to the 2 different groups. All right, so we're going to talk about page 7 together. So it says on top, in study B, the data were collected from 2 random samples of students. Now, if you can just take a minute and just kind of hit pause and reread B just so that you're familiar with the situation again, that would be great. So, okay, letter E says, can the results of the survey be generalized to all 9th grade and all 11th grade students at the school? Why or why not? All right, so the answer here is yes. I mean, first of all, they looked at 9th grade and 11th grade students. These were the types of students they looked at. And really, the real reason here is yes, because the subjects were randomly selected. When you randomly select a smaller population, like a sample population, as long as they're randomly selected, you can generalize this to the population that was being, surveyed as a whole. Okay, letter F says, suppose there really is a difference in the mean number of texts sent by 9th grade students and by 11th grade students. Can we say that the grade level of students is the cause of the difference in the mean number of texts sent? Why or why not? All right, so think about that. Can we say that is the reason? And the answer is no, because this was an observational study. Observational studies cannot conclude cause and effect relationships. An experiment would need to be done in order to determine that, where all the factors are kept the same other than, the one factor they're testing for. So here, no, we could not conclude a cause and effect relationship because observational studies cannot do that. Okay, so the bottom of the page actually goes back to study A, the one about the dogs and the dog food. So it says, in study A, the dogs were randomly assigned to one of the 2 types of food. All right, letter G. Suppose the dogs that were fed the new dog food showed improvement in health. Can we say that the new food is the cause of the improvement in the dog's health? Why or why not? All right, well here, yes, we can say that because this was an experiment. And remember, experiments can conclude cause and effect relationships. So you might want to hit pause to kind of write that all out. All right, and then letter H. Can the results of the dog food be generalized to all dogs? Well, what do you think? I mean, they only really studied older dogs here. So I would say no, it cannot be generalized to all dogs because they only studied older dogs. So no, not all dogs. But then over here it says to all older dogs. And then why or why not? All right, well, yes, it can be generalized to all older dogs because the older dogs were the subjects. All right, so I'm going to read number 12 with you. It says, an orange juice processing plant receives a truckload of oranges. The quality control team randomly chooses 3 pails of oranges, each containing 50 oranges from the truckload. Identify the sample and the population in the given scenario. All right, so I'm going to stop right there. So what I'd like you guys to do real quick is based on what we just read, I'd like you to identify the sample and the population of the scenario that we just read about. Okay, so just write that out. You could hit pause, so you can write that out, and then you could hit play and see how you did. Okay, so here, I'm going to actually start with the population. The population would be the entire truckload of oranges. Now, if the entire truckload of oranges was the population, right, then the sample would have to be the 3 pails, each containing 50 oranges. Okay, that's the sample that they decided to look at in order to determine the quality of the oranges. So let me just kind of put that out here, okay? The sample is the 3 pails of oranges that each contain 150 oranges. So altogether, the sample is, 3 times 50. It's 150 oranges, whereas the population is the entire truckload of oranges. Okay, so now let's just keep reading further. It says, state one conclusion that the quality control team could make about the population if 5% of the sample was found to be unsatisfactory. Okay, so just think about that for a minute. Think about one conclusion that they could make. And, write it down, and then you can hit play and see how you did. Okay, well, if 5% of the sample was found to be unsatisfactory, then what they can conclude is that 5% of the entire population would also be unsatisfactory. So that's what I wrote out. I said if 5% of the sample was found to be unsatisfactory, the quality control team could conclude that 5% of the entire population would also be unsatisfactory. And that's really why we, take a sample to look at, because we, base our conclusion about the population on that sample that we looked at. All right, so number 13, it says, describe how a controlled experiment can be created to examine the effect of ingredient X in a toothpaste. So when this was on the regions, I thought it was a pretty vague question. Really, they're really going to accept a variety of answers as long as you include the components of what a controlled experiment includes. All right, so I'd like you to just kind of hit pause, write out an answer, and then same as we've been doing, hit play when you're done. All right, so here was my answer. It says, the participants would be randomly divided into 2 groups. So this is a keyword. Underline it. If you didn't put that in your explanation, make sure you include the word randomly. All right, they have to randomly be divided into 2 groups. Now, within those 2 groups, you want to have a control group and an experimental group. So I said one group, the experimental group, would use toothpaste containing ingredient X. The other group, which we call the control group, would use toothpaste that does not contain ingredient X. All right, so that's the 2 differences between the 2 groups. One would get the ingredient X, one would not. Then I wrote all other conditions would be kept exactly the same between the 2 groups. So, for example, the quantity of toothpaste used, the duration of time, plus whatever else, is going to be included in there. The effects would be examined amongst both groups over a certain time period. And that's it, okay? You can keep it very vague like that. As long as you say you randomly divide them into two groups, one group gets ingredient X and the other doesn't, and, they study the effects over time, that's a perfect answer. Okay, so the last 4 questions of the packet are just multiple choice, and they really all just kind of focus on what would be the, most fair way to conduct whatever type of statistical study is being conducted in the question. Now, if you can just write this on the top of this page, you're going to see the word biased. Okay, you guys may already know what that means, but just in case you don't, biased means unfair. Okay? Biased means unfair. So let me just kind of take a look at the first one with you, and then you could see how you do on the rest. So it says number 14, a survey is to be conducted in a small upstate village to determine whether or not local residents should fund construction of a skateboard park by raising taxes. Which segment of the population would provide the most unbiased response? So if biased means unfair, then unbiased would mean fair. So we're looking for which one of these would create the most fair responses. All right, so let's go through them. Choice 1, a club of local skateboard enthusiasts. Well, if they're skateboard enthusiasts, they're probably going to want construction of a skate park. So that might not be the most, fair group of people to ask. So I'm going to say, nope, that is definitely not the answer there. All right, number 2. It says senior citizens living on fixed incomes. Well, if they're living on fixed incomes, they're probably not going to want to raise their taxes. So that might also create biased responses. So I'm going to cross off that one. Choice 3, a group opposed to any increase in taxes. So if they're opposed to any increase in taxes, that's going to definitely be biased because they're right away not going to want to raise taxes. So I'm assuming it's choice 4, but let's just read it. Choice 4 says every 10th person 18 years of age or older walking down Main Street. Well, that's definitely going to be a fair way to do it because that's going to include a variety of people. When you just take every 10th person walking down, a common street that everyone can walk down, that's going to be a fair way to do it. So I'm going to say choice 4 is the answer. All right, so why don't you guys read through numbers 15 through 17 and see how you do, and then, you could play the video and hopefully you got them all right. All right, so number 15, the answer is choice 3. If you read through choices 1, 2, and 4, what you would see is, all of these just, interview a variety of people that are randomly chosen. This is every 5th customer to come in. This is, customers chosen by a computer system. And again, this is every customer who enters on a day of the week chosen at random out of a hat. So these are very random ways to do it. The reason why choice 3 would create a biased or an unfair sample is because usually if customers have to take the initiative to call in themselves, people who call in are usually passionate about why they're calling in, so they may, be swayed one way or the other based on why they're calling in. So I'm going to just say that whether, they had great customer service, or usually people call in if they've had really bad customer service. So that might even, wind up with negative results. So choice 3 is the answer here. All right, so number 16 wants to know which statement about statistical studies is true. So choice 1 is going to be the answer. So if you got that right, good job. The other choices, really, they're surveying the wrong group of people, about each category. Like choice 2, a survey of, you wouldn't want to survey 9th graders to talk about student parking spaces because 9th graders aren't drivers. In choice 3, you wouldn't want to survey students to find out about the number of hours adults spend on social media. Maybe you'd want to, survey them to find out the number of hours that teenagers spend on social media websites. And also, choice 4, by surveying calculus students, usually calculus students, right? Calculus is a hard math class. Usually if you've progressed that far in math, I'm not saying all of them, but usually they tend to kind of like math at least. So I wouldn't just survey calculus students to find out who doesn't like math. Choice 1, though, is actually a good variety of people because if you survey all English classes, pretty much I think everyone in the school has to take an English class of some sort. So that would be a good sample to determine the number of hours that students spend studying. Okay, so number 17, it actually might have been tricky if you didn't know what a student directory was, because that is the answer. So just in case you don't know what a student directory is, it's all the students, every single student in the school. So all students in the school. So anyway, just to go back to the question, if the principal wanted to randomly select 100 students, this would actually be the best to select them from. Just, randomly select 100 students from all students in the school. I wouldn't, choice one is only looking at one class of students. The junior class, the 11th grade. Choice three is only looking at one particular class. Like when I say class in this case, I mean math class. Like it's only looking at those students who take Algebra 2 Trig. So that's not, taking everyone into account. And choice four also is not taking everyone into account, because depending on the school district, I mean, some school districts, you may eat lunch, like certain grades may eat lunch during certain periods. So that may focus in on those. Or let's say a certain class is offered during fourth period only. Like let's say music is fourth period only. Then that automatically eliminates everyone who's in music. Or let's say there's a particular like AP class that's only offered during fourth period lunch. Then that eliminates those people altogether. So choice two is really the only answer choice that takes into account everyone within the school.